think I've got the worst slot here because I'm following something like PaveGen, extremely exciting, and talking about power electronics, boring. But boring it may be, worth a lot of money it certainly is. So I'm Jill Shaw, I'm CEO of Anvil Semiconductors. We're producing silicon carbide devices for the power electronics market. Our USP is that we can produce silicon carbide devices for the price of silicon devices. Today, they are 10 times the price. What does that mean? Oops, sorry, I'm going the wrong way. So what are power electronics and why silicon carbide? Power electronics are used to switch and control power in all electrical systems, from your laptop and all consumer devices, AC to DC, from DC to AC on PV, for controlling industrial machines through to the smart grid. Today, those switches are 99% silicon. Silicon is cheap, reliable, and proven. Silicon carbide, on the other hand, if that's used in those systems, could make the systems more efficient, smaller, and lighter. Typical examples of savings on consumer products, we could save 7% of the electricity used. Toyota believes that in an electric car, they could save 10% fuel consumption because of the loss of weight by using silicon carbide. And on PV, you could get 5% more electricity out of your PV system. So why isn't everyone using silicon carbide today? Well, the truth is because it is far, far too expensive. It's 10 times the price of silicon. What Anvil's IP does is produce silicon carbide devices for the same price as silicon, so you can get the advantage of silicon carbide for the price of silicon. So who are Anvil? We're formed in 2010. We're a spin-out from Warwick University, and so far we've had 263,000 invested in us, which has allowed us to produce proof-of-concept devices. As you can see, we're no spring chickens, but we do, with that, bring years of very important experience. I'm an electrical engineer. I've run £200 million high-tech businesses for British Aerospace and then gone into new startups, including taking a fuel cell startup onto the AIM market. Peter Ward has worked in the semiconductor industry on his life, large and small companies in senior positions in operations and new product development, and is the inventor behind the technology. Phil Morby is an academic, well-renowned, and runs the power electronics group at Warwick. So what's important about Anvil Semi? First of all, we have disruptive technology in the semi market. Silicon carbide for the price of silicon. But we're talking about not a technology that's looking for a market, but a market that is screaming out for solutions to its problems. A market that will achieve $5 billion by 2020. We actually have two parallel technologies. I mention this because one we expect to license very quickly for an upfront sum, and we're already talking to power electronics companies to get $3.5 million, which we can reinvest into the business to develop our low-cost silicon carbide devices. And what we want to do is turn the low-cost silicon carbide technology into a business that's worth 200 million turnover by 2020. But we don't expect to get there because it's an extremely acquisitive market, and what we expect to do is be bought up within the next 5 years by some of the large companies. Today, we're looking for 400,000 in order to develop prototype products that we can get into the hands of potential customers, and then another 500,000 towards the end of the year. We've already got half of that promised, but we need match funding. What that allows us to do is produce our first commercially viable low-cost silicon devices. If we look at competition, the tier one semis at the moment are looking at the expensive silicon carbide, but we know that they're very innovative, they've got deep pockets, they will follow as soon as we put our head above the parapet. The other technologies, silicon and expensive silicon carbide, I've already talked about. Gallium nitride has the potential of being low cost, but it doesn't have the same advantages that silicon carbide can bring. If we look at our business plan and say we're trying to turn into a £200 million business by 2020, we're in 3 phases. The first phase is what we're at the moment, is to produce fabricate prototype devices that we can get out into the hands of customers. From then on, we'll then qualify the devices and then build our business from there. If we look at, as I said, we don't expect to get there, we don't expect to get 200 million, we expect to take an exit, and there are lots of examples of companies, as mentioned here, in a similar area that have taken exits that are north of 25 million, and that's what we expect to do. Thank you.